Hey there, and welcome. We spend a huge part of our lives doing one thing, waiting. Waiting for coffee, waiting for a website to load, waiting at a traffic light. But what if there was a science behind all of it? Well, there is. Today, we're going to dive into a surprisingly cool field that helps us understand, predict, and even cut down on all that waiting. So let me ask you this. What could a super busy website and your local coffee shop possibly have in common? I mean, on the surface, they're totally different worlds, right? But deep down, they're both tackling the exact same fundamental problem, managing lines. And that shared challenge, managing lines, brings us to our first big idea. See, before you can make a line shorter, you first have to understand what a line even is. At its heart, it's all about this universal experience of being in what's called a queue. A queue, simply put, is just a line of things that are waiting for something. And those things could be people, they could be cars, or in the digital world, they could even be data packets trying to get through a network. And usually they follow a rule that we all get, because it's fair. First come, first served. If you got there first, you get helped first. Simple as that. And once you start looking for them, you realize queues are absolutely everywhere. I mean, think about it. Students bunched up waiting to get into a classroom, people in line at the grocery store, cars stacked up at a red light. Even the files you send to the printer, they're all just different kinds of queues. So why do they happen in the first place? Well, it really just boils down to basic supply and demand. A queue is what naturally happens when a whole bunch of people, or maybe a bunch of digital requests, all show up wanting the same limited thing, like one barista making coffee or one ATM. When demand is bigger than supply, you're going to get a line. Now, if we knew exactly when everyone was going to show up, managing these lines would be a piece of cake. But of course, life doesn't work that way. And that brings us to the real heart of the challenge, which is uncertainty. This really is the tricky part. 1 minute, maybe one person walks in. The next minute, a group of 10 shows up out of nowhere. We just can't know for sure who's going to arrive or when. It's this randomness that makes managing queues so difficult. So how in the world do you deal with something so random? This is where a really powerful tool comes into play, probability. And don't worry, I'm not talking about complicated formulas here. Let's just think of it like this. Probability is a way for us to find patterns inside all that randomness. It helps us understand what usually happens, even when the future feels uncertain. And this gives us a huge advantage. It lets us look at what's happened in the past and make some pretty good guesses about the future. We can estimate, on average, how many people usually show up every hour, and we can also estimate how long it typically takes to help each person. We don't get a perfect prediction, but we get an idea of the average behavior, and that is incredibly useful. Okay, so we can estimate how many people are coming and how long it takes to help them. Now for the really cool part. Let's see how we can actually use those estimates to balance the system and make those lines shorter. This ATM example breaks it down perfectly. Look at the left side. If 3 people show up every minute, but the ATM can only serve 1 person per minute, what happens? The line is just going to get longer and longer. But now look at the right side. If people are arriving slower than the machine can serve them, the queue stays short, or maybe there's no queue at all. It's all a balancing act. So here's the most important point to take away from this. Probability is the tool that gives us the insight to balance these two things, the speed of arrivals and the speed of service. By understanding how people usually arrive, we can adjust how we provide the service to match it. And that's how you stop long lines before they even start. So far, we've been talking about coffee shops and ATMs, but this exact same thinking is running silently in the background of all the technology you use every single day. So let's connect these ideas to the world of computer science. Smart systems, whether we're talking about a store or a website, follow this simple 3-step playbook. First, they observe past data to learn the patterns. Then, they use probability to predict when the busy times are going to be. And finally, this is the most important part. They prepare in advance, adding more resources to handle what's coming. Think about the operating system on your computer or your phone. You've got dozens of apps and background processes all screaming for the processor's attention at the same time. Well, your OS is basically a super fast manager of a queue, using these exact principles to decide which task gets to run next so that everything feels smooth and responsive to you. It's the exact same story with computer networks. The best way to think about network congestion is just a big traffic jam for your data. So, By using probability to predict when internet traffic is going to be heavy, systems can manage the flow much more efficiently. This makes sure your emails and videos get where they're going without getting stuck in a digital gridlock. And of course, this is absolutely critical for all the websites and apps we use. Think about a company like Netflix. They analyze data to predict when tons of people are going to be watching, like right after a big new show comes out. They then automatically get more servers ready ahead of time so the service stays fast for everyone and doesn't crash, even when demand is huge. So let's pull all this together. This ability to predict and prepare isn't just some neat academic trick. It's what makes our modern digital world actually work. And really, the difference is like night and day. In a world without this kind of prediction, systems are slow, they're always just reacting, and they get overwhelmed easily. We, the users, get frustrated as waiting times just get longer and longer. But with probability, systems become proactive. They run smoothly, waiting is kept to a minimum, and our experience is just better. Seriously, just think about the last time you watched a video online. The reason it probably played smoothly without that annoying buffering reel is because that streaming service used past data to guess that you and millions of other people would be watching. They got their network and servers ready in advance, just for you. That right there is queuing theory in action. Which brings us back to this really powerful core idea. The future is always going to be a little bit uncertain, right? We can never know exactly what's going to happen next. But what probability does is it gives our systems a way to make smart, intelligent decisions in spite of that uncertainty. And that benefits all of us. So, if you remember just one thing from all this, let it be this. Queuing theory isn't just some abstract math. It's a really practical tool that uses probability to make the systems we rely on every single day faster, smarter, and just plain better. Thanks for joining me.